All right, this is the workbook or the video for workbook week 22. Okay, so if you need to pause at any time, I'm going to go through this. Just pause the video and write down what you need to write and keep going, but I'm going to go pretty quickly. So use the pause button to your benefit. Number one, okay, we've done this. If you haven't done this, I'm not going to go through and write all this out because it would just be a waste of your time. But if you haven't done this, pause, go to page 106, copy down to what you learned, copy down all the vocabulary words, copy down the main idea and why it's important. Okay, that's what you need to do to get the check for number one. Okay, number two is over here on page 11. Okay, it says, why do you speed up as you fall? Okay, it says right here, it says, gravity is in the same direction as you are moving, so you speed up as you fall. I mean, that's the answer. So when forces combine in the same direction as the object that's already moving, okay, that object speeds up. The same thing happens to falling objects because they're falling in the same direction that gravity is going. Three, okay, this is a cause and effect. We went over this several times. Okay, the cause is here and what effect it has on an object should be here. And it tells you that in the directions here. So if an unbalanced force is exerted on an object at rest, the object is going to accelerate in the direction of that unbalanced force. Okay, so if an object, you have to excuse me for a second, it sounds like somebody's about to come into my classroom. Okay, but it says an unbalanced force is exerted on an object at rest. That means it's sitting still. So if I take my pen and I apply unbalanced force to it in this direction, the pen is going to move in the direction of that unbalanced force. Okay, and so right here it says that the cause is an unbalanced force applied in the same direction the object is moving. If an object is already moving and an unbalanced force is applied in that direction, it's going to cause the object to speed up. Okay. And right here, it gives you the effect and it wants to know the cause. And so the effect here, it says that an object slows down. Now, if forces going in the same direction cause an object to speed up, an unbalanced force applied in the opposite direction of a moving object is going to cause it to slow down. So if you were running in one direction and then your friend comes and pushes you in the front, okay, that's going to cause you to slow down. And so that would be an unbalanced force applied in the opposite direction. All right, this one right here, a lot of you missed this one because you have to follow the same structure that is in the chart here. Okay, it says you are filling in based on the information that's missing. So here it says it gives you the symbol A. We know that stands for acceleration, and it is measured in meters per second squared. Okay, so if you follow the same format that's listed here, okay, you see here it give you newtons, and then it gave you the symbol. For meters per second squared, you need to write that out and then give the symbol m-s squared. Okay, so that's why a lot of you missed this one. Over here, net force, okay, is measured in newtons. The symbol for that is N. Some of you put N over here, but in this equation, net force, the symbol for net force is F. So that goes there. Okay, kilograms it gives you here. We know that we measure mass. That's mass is measured in kilograms. Okay, and then the symbol for that in this is M. 5. Okay, it says here, when an unbalanced force acts on a resting object, we already talked about this when I showed you with my pen a second ago, it's going to accelerate in the direction of the unbalanced force, so that should be B. And again, we just talked about this. The units of acceleration are meters per second squared. So you can see that if you are doing this stuff and you are doing it carefully, a lot of this stuff just repeats and is meant to do that so it sticks in your brain. But if you're copying people's work, you can't get that. Now, this one just asks you about Newton's second law. And this is true or false. It says the acceleration of an object is equal to the net force acting on it divided by the inertia. So it's asking you about this equation right here. Okay, but acceleration is not equal to the net force divided by inertia. It's equal to the net force divided by the mass. So that's why this one would be false. Right here on the next page, page 17, it says number 8 is the law. This law states that the net force acting on an object is 0. The object remains at rest, or if the object is moving, it continues to move in a straight line with constant speed. We've been over that many times. That is G, Newton's first law. And then we also talked about a law for number 9 that states that all objects are attracted to each other, and that attraction depends on the masses of those objects and the distance between them. So how close they are and how big they are determines how big the gravitational pull between them is, and that is I, the law of universal gravitation. 10. In equation form, blank can be expressed as A equals F over M. That's acceleration equals force over mass. Okay, this is Newton's second law of motion. Okay, so that is week 22. Make sure that you go back, pause, get all that done, and do it quickly so you can move on and catch up.